we ran out of time last lesson to do 10. And the only reason I put that off was because it used similar triangles. Okay, so, and there was one little, I guess, bit that you got to think about. All right, so if we're looking at this situation, you happy? We've got 40 metres across, foot of the building. Haydo, we're still missing you. 2 metre tall person. Hope they play basketball. Walks directly from the floodlight towards the building at 1 metre per second. Now, this is where you can get in a little bit of strife, because initially when I do this, I don't know if your mind works the same as me, but I want to sort of put X here. But that doesn't then allow the 40 to sort of fiddle around. So what we're actually doing is X is your distance from the building. Yeah? And what would that length then be? 40 minus X. And so this dx by dt of how this is actually changing, is that correct? Think about it. A person is walking from the floodlight towards the building. What does dx by dt represent? Okay, the velocity, the rate, not the velocity, the rate at which this is changing, correct? So if they're walking towards the building, shouldn't that be right? So you've got to think about what it actually means. Okay, so the rate at which this X is changing, it's getting closer. That means it's decreasing, so it's minus 1. So, great. We need to get that link between the height, because are you all agreed? How fast is the person's shadow on the building shortening at the instant when the person is 20 metres, 10 metres? So we're wanting to find dH by dt. Agreed? So most of the steps involve what is the relationship? How can we hook up H and X? And that comes down to your similar triangles ratios, if you remember. Okay, it's going to be, I like to go like it's that one. Oh, why am I using white? It's not working. I would say this one divided by this equals the ratio of this one divided by. Okay, so we end up with H over 40 take X. No, X over 40. What am I doing? Mind is working faster than my writing. Over equals, 2 over 40 take X. You could simplify that if you like to. Shall we? Do I want to? I'm probably not going to cross multiply. I'd probably go as simple as saying that this is 80, right? And 40 minus X to the minus 1. Why wouldn't I cross multiply and get rid of that minus 1 and cross that, because then I'd have an H times an X, and then I'd have to use the product rule, which I would avoid. And I'm sure it would work out in the long run, but that's probably better. Would you agree? Okay, so go ahead and differentiate that, please. So H, that's just dH by dt, 1 dH by dt. And then we've got minus 80 times 40 minus X to the minus 2, but then we have to multiply by the derivative of what's inside. So I'm going to be a bit sneaky and then change that to a plus. What have I forgotten? Right, we've differentiated with respect to X, with respect to time. So you have to whack on that dx by dt. And if you forgot, what reminds you? The fact that you've got. Okay, so we're thinking, oh, this is nice, pretty good, going along nicely. So that's our thing, but we've got this. We want to find this X. $20 right? What about if we were doing B? Would it be 10? Yep, because we've used it. So now you just do your quick little subby-dubby in, and I mean, do we need to do that? So now, I mean, if you want to check your solutions, obviously you could do one, sub it in and say, yeah, I'm on the money. I wouldn't sub in that one if I wanted to check. I would go with this one just to make sure that you've got it all hunky-dory. Why wouldn't I do the A? 20, 20, same. It becomes the same. Whereas if you got the 10. Anyway, you don't care. Really. So help me out if I get things. So an airplane passes directly overhead, then flies horizontally away from the observer with an altitude of 5,000. Okay, so we're happy we've got 5,000. Flying. Woo! Okay, so an aeroplane passes directly overhead, then flies horizontally away from the observer, altitude of 5,000, and airspeed of 200 meters per second. So are we calling this x? And so then we would be saying dx by dt is 200. Flying away, increasing away. At what rate? Okay. At what rate is the angle of elevation to the observer changing at the instant when the angle of elevation is 60 and 30? So your angle of elevation is that one, correct? So it's up to you. You can either be going, well, I'm looking down then at this triangle here. Yeah, or you can just say, well, that angle is the same as that one. Does that make sense? So we want d theta by dt. We've got to get a connection between the variable that we have, the angle, and the 5,000. So what are we thinking? It's a right angle. 10. It's 10. So there's your nudge, right? We've got opposite. That calls for a different color. We've got opposite over adjacent. So try tan, try differentiating in it and see what you get. Hello, Hayden. So we're doing question 14, just getting you started. So rectangle PQR has PQ as a fixed length of 20 and QR increases in length at a constant rate of 2 centimeters per second. So, I mean, we could refer to it as QR. Can we just call it X? Okay, so X, would you agree that then dx by dt, it's increasing at a rate of 2 centimeters per second? At what rate is the acute angle between the diagonals? Oh, well, I don't have any diagonals, so let's get that happening. So which one's the acute angle? Okay, that one there. So we're trying to get d theta by dt. Changing at the instant when x equals 15. Oh, yeah, okay. That's theta. Okay, so a bit of a tip for this one. I don't know what you mean by that, but yes. So, yeah, I know you said isosceles, right? But if you went, because you can cut an isos in half and it just makes life easier. We looked at this, I think, back when we did complex numbers sometimes, where we had an isosceles triangle with an angle sort of stuff. If you can cut it in half and get a right angle, your life becomes somewhat easier. So if we look at that triangle, we just take it and make it a little bit bigger. This is now theta over 2. This length here is? Right, so it's x on 2. And what would this length here be, Mac? Right, so that's 10. Bless you. So can you see that we now have a connection between our theta and our x? So it's just like the one that we did before, sort of. So we've got tan theta over 2, and don't get too scared by the fractions, equals x over 2 over 10, so x over 20, or 1/20th x if you so desire. So shall we differentiate that? Oui. Go ahead. So we differentiated. Okay, we just said we've got dx by dt. That was one of the bits of information that we had. Yeah, this is what we're trying to find, but we don't have theta, so how are we meant to? Well, that's when we have to use the 15. So use your 15 to help you find theta, and then see if we can find the rest. Another 10 minutes, and then we want to move on to do the next little bit, because remember, you can always come back and play around with these. It's the same sort of thing going over and over. I did want to do the circle one, but we might not get time today because I do need you to do a fair bit of work over the weekend, finishing off the next little exercise. However, the story is 15 is pretty similar to the example as well. So what was it? 11, 12, 15, similar. 16 is a little bit different. So I just want to try and do 16 and 17 one at a time. And then we'll go on to the next bit, and you can try and do some of the others later on. The dog's bowl, I mean, really. Doggy. So it's all about setting up the equation, and then you can do the differentiation stuff and finish it off together. So, two cyclists. Please have a read. Two cyclists, A and B, living simultaneously. I'm chatting now, thanks. Just for a change. We've got, make my 120 a little bit better. Okay, so we've got 120. One's probably going a little bit further because they're going faster, correct? And the distance between them, oh wait, now I called that x. Oh, that's not straight, is it? A bit shonky. There we go, a little bit better. Okay, without ruining the surprise, we might be using a rule where you might want to use A, B, C, but I've stuck with the X. Okay, so what do we know? This chap is moving out here at 12 meters per second. So what shall we call this length? Yeah, you can call it what you want. Okay, you might like this. This might give you a little bit of a hint as well. You can turn your X into an A. I mean, you don't have to. I did it with Ethan just where I went X, Y, Z. But anyway, if you turn that into an A, what would you be compelled to call this one now? B. And so do you agree dB by dt equals 12? Are we happy? And going along, we've got A, we've got B. What should we call the other one? C. Okay, and of course, dC by dt equals 16. Still good? Okay, so draw a diagram. We'll put our information down. Something is happening when t equals 2 minutes, which is 120, bless you, seconds. What is it that we're meant to do now? Get A. Not a claw grip. Connection. Conjecture. Connection. Right, we want to get a connection between the A, the B, the C? All right, so as much as we would like to, up until this point we've done right angle trig, sadly, there's no way that we can split this nicely. I mean, I guess we could go, but that's disgusting, to use right angle. So unfortunately, it's all about the non-right angle. And we've got two lengths, sort of, and the angle in the middle, so we're going cosine, okay? Which means, what would be our rule? What's A squared equals B squared plus C squared minus 2BC cos A. Now this is looking, I'll kid you not, this is looking disgusting. Okay, so we've got, shall we differentiate? Before we differentiate this, cos A, one of the things that we do know is that, what did they say about this angle? And it's constant, right? It's not going to change. The cyclists just keep going. They further and further and further out, but it's still always going to be 120. So what is cos of 120? Minus 1/2. So we now end up with A squared equals B squared plus C squared minus 2. Oops. So it's minus 2BC times minus 1/2, so plus BC. Groovy? So we are a little bit unsure because what's about to happen? Yes, do that face, Finn, right? It's going to be, oh. So we end up with 2A dA by dt. We end up with 2B dB by dt. Yesterday we were talking about students who struggle with dyslexia, and sometimes it's not always the case, but they can't see the B's, the D's, and the P's. Poor things. Plus 2C dC by dt, and this is where I go, I love my board because I'm running out of room. Oh, okay. Spoke too soon. Spoke too soon. How sad. I still love you though, board. No. Ah, board, I love you, but you're playing with me today. Anyway, do your product rule. Not going to squeeze it in. So derivative of B is 1, but you've gone dB by dt times C plus B. Derivative of C is 1 dC by dt. G. Got comments to make? So, crazy, crazy, crazy. But from your work earlier, don't we already know that we have dB, we have dC, so that's okay. That's the one we want to find, so that's okay. The problem is we don't have the A, now don't call out, we don't have the A, the B, the C, the D, but this is when we have to do the when. So Kel, after 2 minutes, I believe that you could tell me what B is. You're travelling at 12 metres per second, so after 120 seconds, 12 times 120. Do we agree? And similarly, what would C be? 16 times 120. So now, do you agree we'd be able to have B, we'd be able to have C, so that's all groovy. The only last thing we need is how are we meant to find A? We'll actually use the cosine rule, right, with 120. What's 12 times, what's that? 144. 14400 or just O? Just O. I should know that. That's embarrassing. 16 times 12, I do not know. Wait, you? 1,920. So you can just use your cosine rule to find A. Do you agree? Irritating but doable. Go forth. Okay, so you're looking at 17, discussing it amongst yourselves. Thanks, Eth. So Ethan's thinking right angle because he's thinking back to his circle theorems, right? So just wait until we thingy, please. So we're going, and things are looking snazzy because we've got 10, we've got this x, we've got 90. But the bit that's sort of going is this one revolution in 10 seconds. And that's this P is moving around, right? So it's moving around here all the way around in 10 seconds. So how are we meant to get that into it? And that's where we need to actually include the angle that it's going around the circle. Yeah, but we haven't got the thing. Like, I like your thinking, right? And I did exactly the same thing. And I go like this, thinking what? But that is not going to allow me. I mean, let's face facts. The one revolution per 10 seconds, do you agree? It's around the whole circle. So how many angles in the whole circle? Yeah, except we're dealing with d theta by dt. So we're not working in degrees because they said 360. We're working in radians. So it's 2 pi per 10 seconds, which is going to be pi over 5. But the issue is, where is this angle as it's going around the circle? And so, as I said, I did exactly the same thing. And they went, oh, no, hang on, that can't. I haven't got enough information to do that. So then we have to go to plan B. I did say just wait till we do, but anyway. And to save you a little bit of bother, now, where are we going to put our theta? Because it's going around and around and around. And I would say, you know, from, I don't know if you can see this now, Hades, but it's sort of going around, yeah, like so. Keeps going around, and this is going to keep coming around. So where's our theta? If that's 5, that's 5. What's rearing its ugly head again? I shouldn't call him ugly. Or her. Cosine rule. Okay, so that's your hint for question 17. See how it goes. Oh, geez. It's nearly past. Okay, at past I'm going to have to move on. So we're just saying, Hayden, that if you differentiate this, I might as well do it. 2x dx by dt. Derivative of constant, 0, 0. What's that? 55. 25 times 2 is 50. So that's going to be minus 50. What's the derivative of cos? I have to look at my rules, honestly. So derivative of cos is minus sine. So the minuses will cancel. So I get 50 sine theta. Not quite sure why cos gets a capital, but sine doesn't. Okay, and then we go through and we go, well, what is it that I have? I'm trying to find dx by dt, right? Find the rate at which the distance AP is changing, so that's dx by dt. 50, that's okay. Theta, don't have theta. I do have d theta by dt, because we said that would be 2 pi every 10 seconds. How do we get theta? Well, if you look, when x is 5, that means it's an equilateral triangle. So theta must be 60. And they're saying when x is 5, so we've got that one as well. So then you can just pop everything in and solve. Differential equations, and believe it or not, later on we're going to look at separable differential equations. We can separate. Dan, you're right? So it's just a relationship between a function and its derivative. You can have a read of all of that, but very cute. Actually, it said it again. We are going to integrate to verify certain things. We are then going to also differentiate to verify sub one into the other. So if you can have a look at what they've done here, verify that y equals e to the x squared is a solution to this differential equation. We'll just wait because Matt had something vital to say. What was it? What was so vital you were talking while I was? Yeah, what he's wearing to the party. We know all about the party tonight. Anyway, we look. Y equals e to the x squared. How do we differentiate e to the f of x? Well, we write e to the f of x and then we times by its derivative. How is that proving this? Well, we look again and we say, well, hang on, isn't this e to the x squared y? So you've just subbed it back in and then you've got your answer. Sometimes they're like that, sometimes they're not. And of course we know the whole c can make things move up, down, whatever, but your derivative will be the same. You can have a look at this example, please. It looks weird, but it's quite nice. I don't think you'll even need it. So look at this. Verify that y equals x to the 4 is a solution to. We're not even doing this one. Because dy by dx equals 4x cubed. I'm not really sure what they want us to do to prove it. That's just stupid. Okay? The hardest thing that we will do with this little section, I mean, I was planning on skipping one altogether. But we are going to start with B, just to get into the groove of knowing that we can substitute y back in. So very similar to the example that we just did. So you're writing exercise 8C. If you really wanted to go and do question, I think, 19, 20, 21 from the previous one, you can leave a bit of a gap, but maybe we'll come back to the dog bowl when we do revision for people to write. Okay, so we differentiate 5e to the 2x times 2 equals 10e to the 2x. But what is e? Oops, shouldn't have even bothered. Why did I even bother to simplify? I don't know. Because what is this bit here? Because I asked. Oh, yeah. 2 times y. Bang, done. Yeah? I mean, they're going to go on. They're going to ask you some really challenging questions. Not really. I mean, there's the matchy-matchy. That's really cute. Similar. They might even ask you to find, the equation of the tangent. Yes, because you have the derivative of this. You have the derivative. You've got your x value. You've got your y value. You slap it back in, right? So this exercise, very nice, but it's still worth. So please don't skip. Make sure you're reading and you're sort of going, yeah, what is it asking me to do? And then this is your homework, what you don't finish in the next 12 minutes, is same sort of thing, but instead of giving you the y and differentiating, they're giving you the dy by dx and you're having to integrate. But same theory. Now, can you please get a pencil and just write down question 1, put a little star next to I and J and go sub. So think question 1, I and J, when you are integrating, don't forget that you have to use substitution method with your integration. Okay? So that's our plan for today and the weekend, and you have that all done come Monday. 8C and 8D. We've just done into Tuesday. So let's get stuck in and let's hope that we can even get to, or a bit pushing my luck, Let's ride.